Okay, hello everyone. A couple of caveats before we even begin the talk. This was an emergency talk to fill a TBA slot, so it has had very, very little preparation, so it'll be much less polished than I would expect the quality of an LCA talk to be. So I just wanted to mention that up front, and also point out the other wonderful places which are giving talks at the moment, including right across the way. There's an excellent talk in the other room. It is polished, prepared, will leave you feeling fulfilled, not disappointed as you're going to be at the end of this. Okay, so it's a little chaotic. This would normally be halfway through the slide preparation process, and I also have no idea how long it's going to be. So there may or may not be questions at the end, and I may or may not take questions in the middle. Okay, we're going to talk through Bitcoin basics, because I realize not all of you are deeply familiar with the Bitcoin protocol. I'm not going to cover the whole thing, just the bits that I need to lie to you about in order to explain what I've done. We'll talk about Pettycoin as an adjunct network. I will describe all the problems that come with the solutions that I've tried to use, and some of those problems actually have their own solutions, and some of them are outstanding issues. And finally, we will end with status. Okay. So Bitcoin basics. Bitcoin is based on this idea of transactions. A transaction has a number of inputs and provides a number of outputs. These are broadcast through a peer-to-peer network. And you pretty much create your own private key, and you can create a transaction, using standard crypto stuff, all fairly straightforward. Okay. Now these transactions that are flowing around the peer-to-peer network, just SC anywhere, that's fine. Nothing important's been said. And so are there any questions? That was for you entering late, yeah.
Sorry.
Yeah, that's okay. Do you want me to go back to the beginning? Do that again. Just settle, chill, it's fine. Did I mention I don't know how long this talk is, so I have no idea if I'm going to regret this. Okay, so these transactions that are flowing around the network get bundled into blocks. Basically a block header and a whole heap of transactions. While transactions are trivial to generate, you got your key and you sign the transaction away you go. Blocks are really, really hard to generate, involving basically trial and error over a huge range of possibilities to find a valid block. So this difficulty changes regularly to try to keep it down to around about 10 minutes. So more people working at creating blocks, the harder it gets. Okay. So a Bitcoin block looks something like this. You have this header, there's actually some variable length integers in there, but on average it's around about 95 bytes for the header, and then 450 bytes per transaction, and that's even more variable. Now the header, in it has a previous field which refers to the hash of the previous block. So these things form chains called the Bitcoin blockchain. Okay. Now, two people hit the solution at the same time. They will both create new blocks that both point to the previous block. You'll have a fork in the chain. And the rule is the longest one wins. It's not quite true that most work wins, but if difficulty doesn't change, it's the same thing. On the presumption that the majority of people are working on whatever the longest chain is, right? So it's a way of creating distributed consensus. And this really is the killer feature and the revolutionary aspect of the Bitcoin protocol. That using this proof of work system, we can get group consensus on what it is. Now, it doesn't really matter which transactions are correct or whatever, as long as the majority agree that this is the truth. And the longest chain is the truth. Okay. Now, transactions are checked. So obviously, hey, look, someone solved a new block. Can you check all the transactions before you accept the block as good? First you check, yes, have they done enough work? Yes, it's a valid block from that point of view. They found the solution. Okay, let's look at all the transactions. Now, all the transactions have inputs. They must come from previous outputs. So you kind of match them together. It says, I'm spending this previous transaction and this number input and everything. So you check that. Obviously, there can't be any double spends in there. You can't spend something twice. And things like the value of the inputs must be greater than or equal to the value of the outputs. You can't go, oh yes, I'm spending this 2 cents here, I'm putting $200 here. That doesn't work, okay? So everyone checks that they're all good, and away we go on to the next one. Okay. Now there is a fantastic, I'm not going to go into the scalability of of Bitcoin, there are basically two classes of issues. There are ones that are current implementation details, and there are ones that are, theoretically solvable in the future. Some of them require more work than others. But, it comes down to if you want to handle 10,000 transactions per second, you're going to need about 40 megabits a second just to handle the load of all these transactions going through. That's not too bad if you're in a data center, but it's probably not going to happen on your mobile phone. And we're already seeing those kind of limits. Okay, the thought experiment that I have engaged in with this project is, what if we wanted to go to something like 100,000 transactions per second? What would you do? Is there a way to create a useful network without having to suck down 100,000 transactions a second for everyone? In other words, what if we trade robustness for scalability? Okay. Now, it's important here, the project's called Pettycoin. Now, it's important, there are a lot of forks of Bitcoin where you basically fork the project, file off the serial numbers, and start a new blockchain from the beginning, the genesis block, and you go away. These are called altcoins in their parlance. Altcoins basically have one purpose, generally, and that is very close to P.T. Barnum. That's all I'm going to say about them. We are an adjunct network. The fact that some of them was work does not mean that their motives were pure. Okay, no, there are some altcoins which are really interesting experiments. I'll give them those. And then there are all the rest. So this is an adjunct, not an altcoin. It's not a new coin. We're actually using real Bitcoins. And in fact, we mirror Bitcoin addresses in our network. So it looks something like this. You have the Bitcoin network, which is actually much, much bigger than that, but I ran out of time to click dots. And in the middle there, you can see there's a little gateway. And there's the Pettycoin network, which ambitiously already has over half a dozen nodes. At the moment, it has 0, but we'll get there. So this is my vanity address, my vanity Bitcoin address, one rusty R, and a whole heap of little letters. I would send from that vanity address to the gateway. The gateway would spit out the same amount, minus a tad, to the equivalent address on the Pettycoin network. Now, I've used that P- notation to show that it's the same address. In fact, a Bitcoin address or a Pettycoin address, the same format, when you change a single thing, it has a checksum in it effectively. It's actually an SHA. That, in fact, when it's base 58 encoded, makes it look completely different. But that is the same as that, basically. Use capital P. Okay. So you send things into the gateway and they appear on the other side. And similarly, you send Pettycoins to the gateway and it spits them out onto the Bitcoin network. Okay. Let me emphasize this. This is a transaction network, not a store of value. Now, there's arguments over whether or not Bitcoin is a store of value, but I certainly guarantee you that Pettycoin is not a store of value. So we're aiming for a transaction network, not a place to put your money and let it rot. Okay. So if we're talking about, so we've got this separate network and we can do whatever we want with it. How are we going to make a Bitcoiner-like that is more efficient? Okay. Well, the obvious thing when people think of Bitcoin scalability at the moment is the fact that you have to download about 13 gig of previous blockchain in order to use a full client. That's actually grossly unfair. If you prune all the spent inputs, because you can't spend them twice, you actually end up with a few hundred meg anyway. So that's a technical, that's an implementation detail more than an actual problem. So that's not really what I'm talking about. But I'm talking about the other load that you get if you really do go further, and you actually would need quite a lot. So the first thing you think of is, well, let's reduce the transaction size, make each transaction smaller, everything's good. Well, a transaction at its core requires a list of what inputs it uses. You've got to sign it to say that you're actually allowed to spend that. So 64 bytes for the signature and 32 bytes for the previous transaction. And each output, you have to identify a destination, which turns out with the compressed elliptical curve DSA, you can get down to 33 bytes. You can actually get down to 32 bytes and 1 bit, but let's not just go crazy. And specify the amount. Now, in the Bitcoin protocol, that would take 1 to 9 bytes, although you'd never send something that only took 127 satoshis. So in Bitcoin, though, the inputs and outputs are actually scripts. Now, this is amazing. This is a everyone who knows a little bit about Bitcoin points out this is a hugely undervalued part of the protocol. We can't just use it to shuffle stuff around, but these scripts can do a lot more powerful things. But of course, that means they're larger than the minimum theoretical size. So if we want to reduce transaction size, we can do a couple of things. Rather than allowing you to spend, does that mean this mic is on? Rather than allowing you to spend a whole heap of different addresses, restrict you to one address. So you can have multiple inputs, but you've only got one signature. So basically you have to be spending from the same address. That means that you cut down the number. You don't need one signature per input anymore, you just need one signature. And you can also then go, okay, well, I'm going to allow one output, and whatever's left, assume that that is basically paying back to yourself. So that gets you down, with a little bit of other overhead, to 132 plus 34 times the number of inputs. Bytes, which will be at least one, obviously, and probably more. So say we're 200 bytes. So we can halve the average transaction size over the 450 bytes we see in Bitcoin, but we can't shrink it by a massive order of magnitude. We're not going to get our wins from there. People have suggested this before, that we reduce the chain length. You basically go, if it's too old, you're out. It turns out that this doesn't actually help us very much, but remember, because I emphasized that Bitcoin is a transaction network, not a store of value, I like this idea, so we'll probably do it. Just throw away old stuff. And there are other good reasons for doing this. But that doesn't help you with the amount of bandwidth that you've got to suck up to keep up. It just means you don't have to read all this backlog. So the obvious thing, anyone at Google will tell you, the way to scale is to shard everything. So let's shard the network. Okay. Well, that's pretty easy. All of these addresses that stuff's going to is, 256 bits. Well, actually, no, they're 160 bit. So let's just use the upper 12 bits, make ourselves 4,096 shards. Well, we actually have input and output addresses. So if you want knowledge about an address to be in a shard, you may have to actually appear across 5 of these shards, but it's not too bad. A transaction will appear on up to 5 of the shards because it'll have 4 input addresses and 1 output address. So this does give you the nice ability to monitor a single network shard, because if you care about a particular address, people are paying you tiny amounts of money on your address, you just monitor that shard and you will find out about all the payments that go to you. Okay, that's nice. And actually in the protocol, we require you to sit on 2, because otherwise everyone might just sit in their own shard and there'd be no cross-shard communication. So we require a 2 minimum. So that's not too bad. And the other thing you can do, of course, is within the block, in Bitcoin they tend to just append them as they come in to the block that they're working on. In Pettycoin we insist that they be ordered. And we use an ordering, which is pretty obvious, so that all the blocks in the same shard will be right next to each other. Okay. Of course, that's ordering them by output address. In fact, if you care about input addresses, the other ones will be scattered in different places. So if you care about everything on shard 4096 or 4095, that's fine. All the ones that are output to that shard will be in that block, but there'll be other ones scattered around. So we divide these into batches of 4096 transactions, unrelated to the last 4096, just a number I like. We divide that into batches. So we've got a batch like this, and we hash every transaction. The transactions are variable length, so it's much nicer to hash them like this. And then we basically take each of these hashes and hash them together in pairs up to a root. This is called a Merkle tree, and it's really, really cool. So every batch of 4096 transactions gets hashed into one SHA hash value. And we put each of these in the block header. So we've got a 72-byte block header, and then the Merkle hash of each of these batches of 4096 transactions. This means, if I send you that batch of transactions, here's the batch of 4096 transactions, you can do that hash and check indeed, that is the correct batch because the hash matches. Good. But I can also send you a single transaction and a set of 12 hashes and also prove to you that that one transaction is valid. And this is why you do that Merkle hashing. So here we have our hash tree, and there's the green transaction that we care about. Obviously, we haven't got 4096, we've only got 16, but this will expand. So instead of sending you the adjacent thing to hash, you just send me the hash value. Similarly, for the other two, you'd have to get that, just send me the hash value, and that hash value, and that hash value. So I can trace up to the root there and do the calculation I need. So that's actually pretty cool. So what do clients actually need to know to use this network? What they really need is the blockchain of these headers. Now, if we assume that we're doing the same thing as Bitcoin, which is a really good idea if you want to do merge mining. We're going to do one new block every 10 minutes or so. There's 74 bytes plus a hash per batch plus some overhead that we'll see later. It works out to about 650K for 1,000 transactions per second, so around 8 kilobit. We can probably do that. That's probably good. That's a nice number. Okay. Other numbers that aren't so nice. This one's good. Now, to send you a transaction, if you've only got these block headers, of course, I need to actually send you the transaction. Here you go, sir. I wish to pay you, and here's your money. And you go, well, it refers to these other things that you're spending. I'm going to need those too. And, of course, the 12-hash Merkle proof that they actually do exist in the blockchain, and recursively for each of the things that they use. So blockchain is small. Sending a transaction, turns out from the Bitcoin network there are about 2.1 inputs each. By the time you've spent a coin 10 times, you've got about 1,700 transactions you're dragging behind you. Each transaction is about 200 bytes-ish for 2 inputs, 2.1 inputs. Each proof is 264 bytes. That's 788K of data to send. That's about the sane limit. If you're on like a 1 megabit, that's going to take you about 10 seconds to send the transaction to someone. And that's really, at the moment, about the tolerable limit. So after 1 meg, what do? You've got to get it off the network because you can no longer send someone that transaction that large. They will reject it. So, did I mention that it's a transaction network, not a store of value? The solution to all the hard problems is go back to the Bitcoin network. Excellent. Now, there are some to-dos. It would be really nice to have a longer time inside Pettycoin. It would be really good if you could bounce around for a little bit longer, or especially if you're having fast transactions. 10 transactions is not very many. Okay, there are a few ways to do it. One is a gateway re-inject, where you might have the gateway just bounce it straight back to you rather than putting it onto the Bitcoin network and paying a transaction associated with that. We could allow larger transactions, say, well, 10 meg, but you do hit diminishing returns. 10 meg gets you 13 transactions, not that great. We could cut the number of bits in the Merkle proof. I stole the Merkle proof, or the Merkle hash stuff from Bitcoin because inventing your own crypto is always fun, so I have not touched that. You could allow incomplete proofs. Instead of tracing it all the way back to all gateway transactions, you might go, look, if you can prove that these coins have been floating around for, a couple of weeks, I'm happy. All these are possible. Now, what do miners need to know? These are the people actually solving blocks for you. Well, this system of proving that your transactions exist only works if you can guarantee that there are no duplicates in the blockchain. If somebody can put 2 double spends in, then I can send the coin to you and say, no, see, the coin came from here, and send to you and say the coin came from here, and you'll both believe me, because I've put a double spend in. So double spends are clearly illegal. You can't use transaction. Now, the problem is, of course, with no one having full data about the network, this is really hard. In Bitcoin, it's easy. You can just look at it and go, no, you've got a double spend. I'm not accepting that block. If you've got partial knowledge, it's hard. Of course, some shard out there, as long as somebody knows, they can prove this quite easily. I can send you the entire block and go, or I can send you the double spend, the Merkle proof that they've got it in there, and the one that they spent before, and go, see, it's a double spend. And the network will reject the block. It'll only take about 464 bytes for me to send that proof, double that, a K for me to send that proof, and it can spread through the network really fast, and everyone knows they're trying to cheat. So miners, in order to not generate these, will need to check the transaction inputs and not double spends. Or trust the network to filter them, and we'll come to that in a sec. But it implies that miners need to have complete knowledge of the chain. You need to know, unlike the normal nodes, you really need to know this whole thing. So you are going to have to take in 100,000 transactions per second. And that's the trade-off. Okay. There are actually a couple of tricks that we can do. Because you're watching networks go around, and then somebody goes, I've solved the block, and here's all the transactions again, because we know they will be ordered in a certain way, you can actually optimize that and go, I've probably seen most of their transactions, I've got the hashes, let me guess, oh yeah, okay, I know that batch, I can't figure out what you did here, please send me this one transaction so I can figure it out. So there are some optimizations we can do in the protocol, so you don't have to get all the transactions as they're flowing around the network, and then when someone solves a block, we'll get them all from them again. There are problems with partial knowledge, and mainly there are 4. Double spending detection, how do you do it if nobody sees the whole network? Ensuring honesty, mining rewards, and trusting gateways. So, double spend detection. Well, as I said, it's really easy to send a complaint if you see a duplicate. You go, approve here and here, these are duplicates. Okay. But, I'm going to enter an aside here for a moment. The actual way the Bitcoin network works for small amounts at the moment, and something that's kind of nice, is they don't wait for transactions to go in a block. What they do is, They listen for a double spend. The transaction comes in and they go, is there anything else? Anyone else trying to spend the same thing? After 5 seconds, they go, no, I reckon it's good. Because all the miners will have received the first one, presumably, as long as they're attached to the real network, and there are Sybil attacks in here. All the miners will receive the first one, so whoever solves the block will include the first one anyway. Even if a second one comes out that's a double spend, they'll just ignore it. So waiting 5 seconds is reasonable. Can we do better? And there's a really good paper on double spending attacks on fast payments on Bitcoin, which suggests yes, you can. You can basically have a special message that said, oh, I found a double spend. That's a nice idea too, but then you've got problems with, well, are people just going to flood the network with these messages and things like that? And what you really want to do is reward people for reporting a double spend. If you spot someone trying to cheat, it would be really nice to give you some of that money. You can't actually take it from the double spend, however, because that's a different attack, because I can spend once to you and spend once later to you. Somebody spots a double spend and takes the money from you, who would have got it otherwise, not from me. And of course, if I'm deliberately double spending, I will arrange that to happen all the time. So you'll only catch dumb criminals. Not a good idea. Okay, so the other problem that we have is it's hard to prove we found the double spend. So I go, oh, I found a double spend, and here's where to pay me the money. I send it to you, and you go, I found a double spend, and here's where to pay me the money. And we race on who's going to broadcast first. That's a hard problem to solve. One way of doing it is to trust the majority, to be honest, and say most people won't do that. That'll last a couple of weeks. After that, we need an answer, perhaps requiring a small proof of work. So you'll work at it, so just to slow everyone down who wants to fake it. So when they see your report, there'll be a couple of milliseconds behind you, perhaps. That needs more thought. And of course, if this double spend protection on the network works and rewards working really well, you'll never get them. Which means that people would disable that code because it's a waste of time, because they never get any money from double spends, because there never are any, because they're so easy to catch. And we end up then back to the steady state where actually they do start happening because not enough people are actually, okay. So you do actually need to fake inject double spends to provide incentive for people. But if you provide too much incentive, they're going to start cheating again. So that's a little bit of a to-do. Okay, ensuring honest miners. So your miners are following the entire network and they're hashing everything and they're doing everything else. Now, they can say, I solved it, and not send out the details of one of the batches. Most of the network will be happy because they've got the batch that they care about. A small part of the network, say around about 1 in 2,000, will be unhappy about not being able to get that information, but that's okay, most of the miners would carry on. You really want, and if you manage to hide a transaction in the network, you can reveal it later. You can do cool things. You can later on spend something and go, haha, it was a double spend because back here it was in the block, and prove that it's so. You can also invalidate a future block you doing that. So a miner you don't like solves a block, you go, no, that transaction you put in, I had it here first. And you just invalidate their block. To get around this, you have to prove that you knew the last 10 blocks worth of transactions. And the way you do that is you prepend your address to each previous transaction and do the Merkle tree trick again. So you Merkle it with your unique, your payment address, effectively, in the Merkle hash. So I can check when I see your block, I know the transactions to the previous block, let me check, yep. We stick these at the end of the header, we just use 1 byte, that gives you 1 chance in 2056 of getting away without knowing it, but that's pretty low. And so we Merkle hash the previous 10 blocks, okay. Now 10 blocks may not be sufficient, there are some ideas about spacing that out. The other problem is that what if someone does get away with this? Somebody manages to hide a batch, and 3 days later, they pull it out and reveal a double spend in the block afterwards. Now do you go back and go, all those blocks are now invalid. We have to go back 3 weeks or whatever it was and recalculate it? Or do you just eat that up and go, okay, if we limit the number of transactions in a block and restrict the amount in any transaction, do we just go, look, if you've managed to get away with it for more than a week, whatever, we'll just eat the loss. And people will double spend. I don't know. Mining rewards. So in Bitcoin, you get a reward for mining. To start with, every time you mined, you solved this block that was really hard, you got the transaction 0, which you had an implied input of 50 Bitcoins. So you basically said that to yourself, thank you very much. And that's how Bitcoins got created. This halves every 4 years or so, so it's currently down to 25 and it'll keep going exponentially smaller. You also get anything left over from transactions. They've got inputs and outputs. If there's a difference, that's called a transaction fee. You get to collect all those. The plan is over time, this will increase and you go away. Now, if you're an altcoin, that's easy. You just, rusty coin, away you go. Here, have 50 have 100 rusty coins. There you go. And you convince miners to get on board using the same system. We can't mint Bitcoins. If I was, I wouldn't be here. I'd be on an island somewhere. But without full knowledge, we can't use transaction fees. When everyone knows all the transactions, they can add up the transaction fees and away they go. They know that you can spend it. We can't offer a flat fee because then you just go, well, whatever, I'll solve a block, but I won't bother with this hassle of collecting transactions stuff, which was kind of the point of people doing blocks, is to put them in transactions. So, mining rewards, at the moment we don't have any, but statistical awards. You have a special claim transaction, and you select a valid transaction that was in your block in full. You go, here's the transaction. You prove that it was in your block using the Merkle hash, and use a recent gateway transaction that says, here's the outstanding reward for mining. And based on how similar the XOR, basically this random number, which is the XOR of the hash of the next 100 blocks, which you can't possibly control, and the hash of your transaction. So you pick your transactions as closest to that, and the more similar they are, the bigger your reward. This encourages you to gather more transactions, because the more transactions, the better shot you have at this lottery. And it's very easy for someone to check when you spend it. So statistical awards are probably the way we're going. However, you still have this problem that you don't have a nice decay. Statistical awards are basically an indirect form of mining fee because the gateway is collecting these to send to you. Those rewards will really suck for the first couple of years, even if it's successful. So the Bitcoin model was reversed. You got big rewards up front because no one knew it was going to work, and then they decayed. If you rely on transaction fees, you get the other way, and it doesn't work as an incentive. So, oh yeah, and you know how I said there should be an incentive for detecting double spend reports? We could kind of go, well, the other thing you've got to put in this is a double spend claim that someone's done, in the hope that what you'll do is you'll deliberately inject a double spend into the network. Someone out there who's listening will send you the thing saying, hey, I found it. You'll put that in, and they'll get 1% of your reward as a bit of a bonus. 1% being a small enough tax for a miner to go, it's worth it to make sure the network works properly. Yeah, a little bit dodgy, but it is a bit of an honest system, but it's the best I can come up with at the moment. The other way to do mining rewards is to tax the future to pay for the present. Now, I know that this country doesn't have a great history with mining taxes. But, for example, after 4 years, you could say 50% of the rewards at that point are actually going to go back to the people who mined right at the very beginning. Okay? On the theory that adoption will be like this, surely. And if you mine now, you've got a shot of basically sharing in the rewards that will happen in 4 years' time. Obviously, you need to smooth that, and you can guarantee whatever you choose, it'll be wrong. It will be grossly unfair. It'll either be far too generous or far too ungenerous. But you have to nail it at the beginning so everyone agrees on what it is in the protocol before you have any idea of what's going to happen. There is another issue, the trust in gateways. The gateway is actually holding your Bitcoin. You can monitor it, right? You can watch the Bitcoin and Pettycoin network here. Yes, it is being honest, everything else. But you still have to trust. Thus, it will only relay very small amounts of Bitcoins. And it's also a good reason for limiting history. Because I don't want your money. I really don't want your money. This is why did I mention it's a transaction network, not a store of value? Well, I certainly don't want to store your value. So trusting gateways is a problem, but it's a good reason for limiting history. Basically, get your coins back out as fast as possible. Excellent. There are some to-dos. We could use multi-signature transaction to have independent gateways, so they would have to collaborate to release the results. Clients could potentially differentiate Pettycoins based on what gateway they came from and levels of trust. That's, open issue. I don't know that will even work. But how do you bootstrap this? This is the long run. Obviously, you use testnet. There is this great thing in Bitcoin where they have two networks. They have a testnet and a real net. You can basically flip across the testnet and do almost anything you want. So obviously, bootstrapping, we're using testnet. And for bootstrapping, we're also using full knowledge. All this idea about having partial knowledge is really, really fragile when your network's so small that somebody can run in and basically dominate the network by mining all by themselves. So while it's small, full knowledge, of course, is really, really easy anyway. So to bootstrap, you just say, no, everyone's going to do full knowledge. And also, to be nice, the gateway, because it will have full knowledge, as funds expire, if you haven't sent them, it will actually push them back automatically onto the Bitcoin network. This is actually really nice. It means, in theory, you can use Pettycoin to pay somebody who has never heard of Pettycoin, because a month later, if they haven't collected it, it will get spat out onto the Bitcoin network for them. That's actually kind of a nice feature. It doesn't scale very well because it implies the gateway would have to know every single transaction on the network, which is something we're trying to avoid. But certainly in the Bootstrap phase, it's really, really important that it will spit those back out. Okay. Wow. Can you have both?
Yeah, like gateways that have like the full knowledge, so that maybe you could pay small fee to have a gateway that will return the coins back to the Bitcoin network if they're not collected.
I look forward to your patch. He asked, could you have some gateways that perhaps charge a bit more, but they guarantee that they'll return stuff to the Bitcoin network? The reason not to do that is that the point of putting on the Pettycoin network is to send the Bitcoins to someone else. So you're basically paying a fee so they get their money back. Eventually, right? And that's not quite right. Certainly it'll happen at the moment. The other thing that actually, if you want to pay for something, is you can pay to go, does anyone know the proof chain for this transaction? If you have full knowledge, it's easy for you to generate that. So if someone has to connect to you to send you money at the moment and give you all the proofs, if you want to be really lazy, a la modern Bitcoin style, before 0.90 comes out with the transaction protocol, you can just have them inject stuff and then go, someone sent me this, can someone prove that it's valid? And you might even pay them in Pettycoin for that. You might give them a tiny amount. Okay, so an example application, because I realized I've talked all about the technology, and I thought, what would we actually use this for? I have no idea. I'm a kernel programmer. We tend to write code that works, and we have no idea what people use things for. But I did try to think about this, and I thought, wouldn't it actually be kind of cool to tip 0.1 cent to every ad-blocked web page you visit? You know, people are providing me some value here. It would be nice to spread some tiny amount of love to them if there was a reasonable way of doing it. This would actually be a pretty nice use for microtransactions. Of course, immediately you think, actually, no, because then people would sucker in your clicks just to get you there to get your 0.1 cents, so it's got a tip on the way out, or it's got a delay so you can go, no, I didn't mean to click on that, etc., etc. But it would actually be kind of nice if we had a scalable, cheap microtransaction network. This is the kind of stuff we could do. Okay. Status. Pettycoin.org is registered. It doesn't point anywhere at the moment. It's parked, but it is registered. So yeah. The block generation code works, so checking blocks and everything else works. The nodes do actually talk to each other. That works. I have a you need somebody to be mining, somebody to be trying to solve blocks. In practice on the Bitcoin network, you're not using CPU mining anymore. On the Pettycoin network, you still are, and the world's least optimized CPU miner is implemented and mostly works. You can inject the gateway transactions. Yeah, normal transactions, the ones that actually spend money. Yeah, I was working on that when I decided to stop working on that to write the talk. Yes, that's because I had 2 days' notice for this talk to fill the slot. So I chose to actually write the presentation rather than writing the code and then showing you page after page of code. The Bitcoin gateway, I have one partially written in shell because I want it to be secure. So it's actually easier than you think. I mean, it really is dumb. It basically monitors Bitcoin stuff and just spits out transactions. You want your money back? That definitely hasn't been implemented. But putting money onto the Bitcoin network, the Pettycoin network, is not quite there. And of course, you'll need like a Pettycoin Explorer. 1, because people want to verify that the gateways are doing the right thing, and 2, because you want all the pretty graphs and to see where how the network's going and what's happening and all that stuff. And of course, there's presumably going to be an HTTP transaction receive code that will receive one of these transactions and all the proof and do something, and that definitely isn't written. Now, before I take any questions, which I will, there is an FAQ. What if your code sucks? What if the protocol has a flaw, and I'm sure it does? What if you hack the gateway? What if it gets shut down? What if someone holds a gun to your head? The answer is pretty straightforward. Okay. And final disclaimer, this is not a promise or a spec, because as I implement things, I tend to go, that was a dumb idea. And I have no doubt that peer review will reveal far more of them. Now, as I was standing on this lectern just before my talk, I uploaded the code to GitHub, so it is very, very fresh. I've been working on it in my spare time for a couple of months. It is a couple of good rewrites away from being decent, but there it is. So it exists as of the beginning of this talk. And with that, are there any questions? Okay, let's do a sweep from the left. You're the first.
Oh yeah, so one of the problems that you're kind of optimizing this for is the fact that to get into the blockchain, you're looking at huge amounts of bandwidth, especially when the transaction numbers go up. So I actually think that's a feature, not a bug, because it stops people from running wallets on insecure things. It's a really good argument. Disclaimer, I work for iptables, and so we're all like, yeah, use bandwidth. But there's a really good argument for having kind of a secure appliance, like a stick that you stick into your second or your USB connection, and it's doing your own kind of, you're doing your verification off of the main blockchain. So I'm just trying to think of interesting use cases where this is useful. And the first one, when you started and kind of moved away from this during the talk, was more around the POS kind of use case, where, you know, at the moment you're looking at how to get a verification of a transaction, so it's just useless for that use case.
Yep. No.
No.
No. Okay. Not point of sale. Not no. Think coins, not notes. I do not want to be dealing with. In fact, I'm tempted to limit the protocol so you can't send more than 0.0, like 1 millibitcoin in the protocol, right? You've already got a limit of 4 bitcoins because I use a 32-bit number. I might throw away some more bits just to be annoying and limit you to I really don't want tiny amounts. The reason is I have thrown away a lot of the things that are really good about Bitcoin to make this. And I may throw away more to get it to scale more. So the idea is that this is the amount of money that you probably don't care about because it works 98% of the time, right? And as long as people can compromise individual transactions but not the whole system, there may actually be room for that. As long as it scales, as long as you can make it cheap enough that transaction fees across this network will be a small fraction of whatever they are on the Bitcoin network, then that opens up for microtransactions. That is absolutely what I'm aiming for. And also the fact that if everything below a certain, so one option was actually to nail the fees in as a percentage. So that way you'd go, well, you'd never use the Pettycoin network for that because it's going to be cheaper to send it on the flat fee Bitcoin network. But below this, it becomes much more attractive. Really bias it to basically trying to take away the dust transactions and go, actually, you have that network over there for those. Different trade-offs, but put those over here. But we're not trying to solve any of the 60-minute delays that you get if you really, really want to make sure that the Bitcoin's been transferred and stuff like that. We're very much going, you're currently doing microtransactions on the Bitcoin network, so you're not waiting for confirmations or anything else. Can we build something that's comparable with that, maybe even a little bit better, with that trust model, and basically do that? So that's not that ambitious. Yeah?
If you limit it to the number of bits, how does that work with scalability as the value of the coin goes up?
Okay. Where's that slide that I don't have? Damn. Okay. I added a slide here which has vanished. Okay. So in the protocol, in both the header of each transaction and the header of the block is a features and a version number. And the idea is that when you want to change the protocol to update something, you set a bit in the feature bit. So everyone who understands that feature starts setting the bit in the feature bit. The miners go through and basically go, if I understand it and 50% of my transactions understand it, I set the feature bit. So in the blockchain, you can see these feature bits appearing. After 2 weeks, if you've got more than 50% of nodes that agree with the feature bit, then in 2 weeks' time, the version number will increment. So you start spraying up to all the users going, there's this new feature bit, I don't understand it, but it's now past majority, you have 2 weeks or whatever it is, to update your client. So we can fairly aggressively roll the protocol, particularly in the early days. So we could do things like, no, actually 0.001 Bitcoin is now worth $1 million, let's not do that, let's drop our transaction levels. But the other way is limiting it simply in the gateway code. Limit the gateway and let you only put in tiny amounts, which I would definitely do at the beginning because it's like, what? Like, if you send a Bitcoin through the gateway, you are insane. Just send it if you want to just get rid of your money, send it straight to me. You saw my vanity address there. It's much, much simpler. Does that answer your question? Yep. Yeah.
So before when you were talking about the miners doing the same simultaneous proof of work, the longest chain wins, isn't that a big disadvantage? disincentive then for the miners that they're trying to solve a problem to get rewarded and somebody else solves the same problem ahead of them and try again and try again? I'm just wondering how that's arbitrated that you don't end up sort of wasting a lot of time trying to solve problems that other people always solve.
Oh, you would definitely, okay. The question was, don't you end up wasting a lot of time as a miner because, you know, someone else, you're working on the same thing, someone else solves it. That's the whole point. You are spending time, not necessarily wasting it. The fact that someone got it is a statistical indication that this many other people were working on it. That's actually quite important. You will not get most of the blocks. In fact, it's a thing called a 51% attack, which you can do if you do get most of the blocks, and you've got half the hashing power. And we are particularly vulnerable to that because if you can control blocks for 10 in a row, you can hide transactions. So once we've gone out of Bootstrap phase and we don't require full knowledge at the moment, of course, you can't do that. So yeah, in practice, you will almost certainly not be the winner in this lottery. But we can use statistics on how fast that's happening to know how many people are competing. And that's basically what it's about, to try to get the majority view. So you'll be spending most of this time not getting the answer. Cool. Any other questions? Any hard questions? Who's found a flaw already? Yeah, no? Okay. Found a flaw in the protocol already? No? I have one.
Can I just follow up on that question?
Sure.
So, if most of the time other people are beating you, is there anything built into the model that you will, you know, not always be beaten and just always sort of spend all this effort and solve?
So the question is, if most of the time you'll be beaten, is there anything built into the model that guarantees that the universe will somehow become fair? And the charity of your peers, perhaps, is your fallback at this point. Someone might feel sorry for you and give you a block. No. If you can't keep up, what will happen is you won't be able to pay your electricity bill and you will stop mining. That, in practice, is what we've seen. Yeah.
Are there any similar or alternative projects to this, and how do they compare?
Okay, similar or alternative projects to this. I haven't seen anything exactly right down this road, which is why I've been working on it. There is a temptation in the Bitcoin space, particularly, to release an idea or a paper and say all someone's got to do is implement it. I tried really hard not to do that. And in fact, I wasn't going to talk about this at this conference until there was a slot that they needed filling, because I wanted to release the code first, have an implementation, go, now knock holes in it, please. Rather than, hey, I have a really cool idea for Bitcoin. I am sure the core developers hear that about 28 times a day, maybe 28 times an hour now. So there's everyone going, oh, this would be really cool. Kind of like, well, here, go away and read these papers for a start and realize, you know, and then start your crazy altcoin after that. Yeah, sorry, up here and then down here. Yep.
Question, as I see this thing, eventually you're probably going to want to distribute it because this node running it, the gateway node, is a very obvious point of failure.
Yep.
Have you thought about how you might distribute that?
Yes, so the gateways can be, the question was, how do you distribute the gateway because it's going to become a central point of failure? Obviously there can be lots and lots of gateways if they all share the same key, which is a different mode of failure, or you can trust multiple gateway keys. So you can, just standard thing where the gateway signs all the keys and then you trust any of those keys. If you go, oh, this is really a gateway transaction. On the test network, anyone can be a gateway, but in real life you will actually go, yes, I trust the following gateways. And the gateways will have a way of revoking their own trust and saying, I'm compromised, go away. You'll probably want to run them on the Tor network because they will be targets. There are all kinds of security issues around running the gateways.
Yes, in the post-NSA world, you might want to say, I haven't not been compromised.
Yeah,
you stop saying that.
Yeah. I don't think in Australia we're bound by quite the same laws, so I think I should be okay. It's pretty easy for me to pull the plug on the whole thing. In fact, one failure mode is for the gateway just to spit out all the coins back to everyone on the Bitcoin network and shut down. In fact, we can flush, if you've got a 1 month timeline, you can flush the entire network and start a new one. You can go, we're all moving over to this Pettycoin network, we're stopping processing transactions here, and everything will just decay, and all the Bitcoins will flow back out of that network within a month. So there are all kinds of actually graceful ways to shut it down. But yes, we can scale the gateways, it's not a huge problem.
I'm just thinking more of the biggest problem Bitcoin solves is that every other digital currency has had
centralized.
Point of failure.
Yes, I hate this fact about the gateways. We could do multiple untrusted gateways and you could require multi-sig. So you basically write a transaction that they can only spend if 2 of them agree. That's the closest I can get at the moment. You can do that in the Bitcoin protocol today. So that's actually a fairly trivial thing to do. But then you're trusting 2 gateways. I mean, you haven't really solved this distributed problem. That's why I'm really interested in thoughts on how you would have a gateway rating system where people would decide based on where the payment comes in, how much they value the coins. But it does make it a lot more complicated. So that may be, if somebody comes up with a great solution, I would expect to rev the protocol to include it. So keep thinking. I look forward to your patches.
If I think of anything, I'll tell you.
Excellent. Next. Yeah. Oh, okay. I will answer you, and then you, and then you.
Having trouble accessing the page. You're just having trouble.
Oh, you're 404ing on my GitHub page.
Yes.
This DOS GitHub.
No. Okay. Thank you for that. I will try to sort out what's going on afterwards. But yes, I did push it.
Any change in how it handles network splits?
Any change in how it handles network splits?
The same as Bitcoin, recent.
Badly. Yeah, so peer-to-peer networking is hard, and my code is crap. So we probably do far worse than the Bitcoin network at the moment. So yeah, network splits are potentially a real problem with any of these systems. Okay, we have one more question. Whoever holds their hand up highest gets it. Yeah, you're actually slightly, I'm sorry, he's slightly taller than you, so yes.
So this is designed to handle the fact that we're getting more and more transactions per second. But if we predict that that will just continue to grow exponentially, is there something built into Pettycoin that allows, that can handle any amount of transactions per second by kind of increasing decreasing the size of the, by doing some magic?
Okay, so can we scale, is there something built into Pettycoin that we can scale infinitely should we need to? You can increase the number of shards. If you increase the number of shards, then your network becomes a little bit more scattered. You still have the problem, so you can shard up. Right. At some point, that stops paying off because there's one person in each shard and it doesn't really work. Because you still need all the shards to talk to each other on some level. And some people are going to need to follow it all, so the miners are. You can increase the batch size, but there are some cases where you have to send someone an entire batch to prove something is wrong. And so the bigger the batch size, the bigger that complaint has to be. And the harder it is for that to get through the network. And the more chance that someone will insert that deliberately and flood the network with what now becomes a multi-megabyte complaint that you have to receive in order to realize that something is invalid. So there are all these trade-offs. The trade-offs may change over time, which is why I really like the features and versioning system, so we can rev the protocol. And I like the fact that we're dealing with tiny amounts of money, so if I break it, meh. The problem is that tiny amounts of money, of course, can add up. So, but hopefully, if people lose the price of a coffee, they won't come after me with a pitchfork. So that's sort of the aim.
Digital currencies then have an inherent maximum transaction per second?
Do digital currencies have an inherent maximum transaction per second?
That would be an interesting research paper.
Yeah, laws of physics may come in there somewhere. Yes, I don't think we're close to it though. No, we are definitely, yeah, this isn't even, it'll be way beyond this. Okay, I think that's all we have time for. Thank you.